Section 3.1, Adding and Subtracting Fractions with a Common Denominator. Okay, first let's just be clear what we mean by common denominator. In this addition problem, the denominators are both 8, and by common we mean they are the same, so this particular fraction problem does have common denominators. Here's another fraction addition problem. One denominator is 8, one denominator is 7. They are not the same. So these fractions do not have common denominators and cannot be added as shown. Let's see why this makes sense. Let's take something that we would understand, our money system, and let's say we have 6 dimes and we want to add 3 dimes to it. So let's turn this into a fractions problem. The first set of dimes, it would make sense to write this as a fraction of 6 over 10. The numerator, as you recall, is the number of equally sized objects that we're looking at, and 10 is the number of objects in one whole. Since a dollar is considered the whole in our money system, then there's 10 dimes in $1. So this as a fraction would be represented as 6 tenths. Likewise, if we were to add 3 dimes, it makes sense that it would be 3 dimes over 10, where there's 10 equally sized pieces in one whole, or a dollar. So therefore, we can go ahead and add the numerators. 6 plus 3 is 9, but we keep the denominator. And it makes sense that we don't add the denominators because this hasn't changed. A dollar still contains 10 dimes. And so we have 9 tenths of a dollar, or 90 cents. This should make complete and perfect sense in our money system. So let's take a look at an example where it doesn't make sense. We keep our 6 dimes as before, but now we want to add 2 quarters. So as a fraction, 2 quarters would have to be written as 2 over 4. There are 2 quarters, and there are 4 quarters in one whole. In this case, one whole dollar. So if we tried to add these, and we added the numerators and got 8, what would the denominator be? They're not the same. They're not dimes and they're not quarters. We have 8 and it's a mix. So we cannot add fractions that do not have common denominators. It just doesn't work. Okay, with that in mind, let's just look at the easy steps involved in adding fractions with common denominators. All you do is step 1 is add the numerators. You keep the denominator and then write the sum in lowest form. So in this example, you should first look at your denominators and agree that yes, they are common. Therefore, these fractions can be added. Step 1, add the numerators. 3 plus 2 is 5. Step 2, keep the denominator of 8. Step 3, ensure that it's in lowest form. 5 over 8 has no common factors. It is in lowest form. Another example, yes, we have common denominators, in this case of 10, so the fractions can be added. 3 plus 5 is 8. We keep the denominator of 10. Step 3, reduce it. Well, these are both even numbers, meaning they're divisible by 2. So we'll go ahead and reduce this fraction to 4 over 5, and that is in lowest form. One more example. Again, look at the denominators. They are the same, so we can add these fractions. We add the numerators. 3 plus 2 is 5. 4 plus, we're not adding the denominators, so don't do that. So just keep the denominator. And then take a look. If we have to convert this to a mixed number, which we likely will have to do, then as discussed in the previous examples and previous sections, the answer would be 1 and 1/4. If we're subtracting, the only difference is instead of adding the numerators, we subtract the numerators, but everything else remains the same. So once again, we take a look at the denominators. They are the same, therefore we can subtract these fractions. 3 minus 2 is a 1. We keep the denominator. 1 over 8 is in lowest form. So we are finished. One more example. Denominators are the same, so we can subtract these. 9 minus 5 is 4. Keep the denominator. And step 3, reduce it. If we divide these both by the common factor of 2, it reduces to 2/5. That concludes section 3.1.